Ha.
Okay guys, we are back with the second lecture from module number 1 of chemistry. We're going to be doing unit conversions. This is probably going to be another 45-minute lecture. It won't be much longer than that because we're going to get kicked out of the library. But first, the moment you have been waiting for, lame joke time. Even in chemistry, what is big and hairy and pink and stomps around in swamps? Pigfoot.
Are you done?
Yes, I am done, Matthew. Okay, what we did in the last lecture was introduce the topic of chemistry. And we also talked about the metric system. We talked about different prefixes. We talked about base units. And you need to have open next to you either your book or the notes that you have where you have the equivalency chart, so that you know the relationship between a cent, what centi is, which is 1/100, what kilogram is, or what kilo is, which is 1,000. So if you have a kilogram, it's 1,000 grams. If you have a kilometer, it's 1,000 meters. So that's what we're going to start working on. First, we're talking about converting between units. So let's say that you measure something in millimeters, which is the type of measuring that you're going to be able to be doing in chemistry. You have to be able to change that from millimeters to centimeters or to meters. And in order to do that, they do what they call unit conversions. And unit conversions are all based on the principles of multiplying fractions together and canceling common factors. So for example, please do not click that. If you had 7/64 times 64 over 13, you could go ahead and do this multiplication out, and you would come up with 448 over 832. Multiply the numerators together, multiply the denominators together, and you get this ugly number here. Well, in order to use fractions appropriately in math, that always has to be reduced to lowest terms. So you'd have to go through and factor this, pull out the common factors, and you would end up with 7/13 eventually, but you could not use that as your answer because it's not reduced to lowest terms. Really? I can't go any lower than that?
Not really.
Not really. Okay. Can't go any lower than that. But something that you learned in algebra that is just so extremely valuable when you're working with unit conversions is the fact that if you have the same factor in the numerator as you do in the denominator, you can cancel those out. So we have a factor of 64 in the numerator, a factor of 64 in the denominator, and we immediately and very easily arrive at that answer of 7/13. And that's that same idea is what we're going to be working with unit conversions, because what happens is just like you can cancel common factors, common numerical factors, you can cancel units. Because remember when we've talked about fractions and we've said that anything divided by itself is equal to 1? Well,
You said we can cancel common what?
Units.
common units. So just like 64 over 64, you can cancel those and it just becomes anything divided by itself is 1. If you have inches divided by inches, you can cancel those out. And that's what we're going to use when we're doing these unit conversions. So let's say, for example, we have a problem in chemistry, and we have been said, first let's go ahead and measure this pencil. So we're going to measure the pencil. Pencil measures 15.1 centimeters. And we're using our abbreviations, and Matthew, you need to be writing this problem down because you're going to copy it. 15.1 centimeters, and our question says to give the length of the pencil in meters. So if you're going to be able to solve this problem, you first have to know the relationship that exists between centimeters and meters. So we want to change this into give the length in meters. So we learned that the meter was the base unit in the metric system. And we did these prefix units, so we learned what centi is. So what is centi?
1/100
1/100.
equals
So 1, okay, so centi is 1/100th. So what is a centimeter? It's 1/100th of a meter is a centimeter. So we have to have this, a relationship between them. So a centimeter is 1/100th of a meter. Now remember, if we have the same value in the numerator that we have in the denominator, it's equal to 1. They have the same, they're in balance. So if we're going to have meters in the numerator and centimeters in the denominator, where is that 0.1 going to
on
be?
the top.
One 1/100th of a meter is equal to 1 centimeter, because it takes 100 centimeters to equal a meter. So this is the existing relationship that we have between centimeters and meters. Now, we're going to just set this up like when you convert fractions from 1/2 to something written over a denominator of 7. I don't want to do that. Denominator of 8. 1/2 is equal to 4/8. You guys know that. That's easy. But when you're just first beginning to do that, you learn that you have to multiply the numerator and the denominator by something. So what we're going to do here is we're going to change our fraction, change our initial measurement into the form where it looks like a fraction. And then we don't want centimeters anymore, do we? Because we want to express this in terms of meters. So just like you can cancel common factors, you cancel common units. So if we have centimeters in the numerator, we're going to have centimeters in the denominator, right? We have a relationship that we have used, that we have determined exists up here. There's a relationship between meters and centimeters. And that relationship is that 1/100th of a meter is equal to 1 centimeter. So 1/100th of a meter is the same as 1 centimeter. You okay at this point? So now we want to cancel common factors. Also cancel common units. The only thing that we have that we can cancel is centimeters, right? So now we have 15.1 times 0.01 meters. So let me write this over here. 15.1 times 0.01. If we wanted to do that long division, 1 times 15.1, so we have 151.
You said long division.
Yes.
Long multiplication, if we wanted to do multiplication. Where does the decimal point go?
In front of the first one.
It goes in front of the first one because there are
behind the decimal.
3 spaces behind the decimal. So 15.1 times 0.01 meters is equal to 0.151. And then you have to put those units in there. Remember we said last lecture that numbers are meaningless without units. Now, what's another way that you could have multiplied by 0.01? If you don't know this yet, you're going to learn it soon, but 0.01 is 10 to the minus 2. And when you multiply by a negative power of 10, all this says is that we're going to move the decimal place 2 units to the left. which gives us 0.151. But for now, 15.1 centimeters is the same as 0.151 meters. And that's all unit conversions is going to be. So let's look at this next one. And they'll give us a little bit more of a pattern that we can follow. Okay. And this is the formula to follow. Everybody needs to write this down in their notes. First thing that you do when you're converting units is write down the measurements that you know, which in the case of the pencil was was just meters. Okay, 15.1 meters. Write the measurement. You know, that makes a whole lot of sense. Write down what you have. Second, you're going to want to rewrite that as a fraction. You know, make it a rational number. Rewrite as a fraction by dividing by 1. The third thing that you're going to do is you're going to complete the conversion, you know, because we're converting from one unit to another. Complete the conversion by multiplying by the, and I'm going to say relationship, by multiplying by the, in quotes, by the relationship. And what the relationship is, that's what we call a conversion factor. And then finally, the last thing that you're going to want to do is you cancel, you know, like units cancel. You remember that just like common factors cancel, like units cancel. And right here, you are just like very happy because that makes your problem much easier to work with. And this is a method of converting from one unit to another unit. And what they call this, it's called the factor label method. Factor label method. And this is another one of those things that I don't ever remember being told that this process is called the factor label method. But in your text, whenever they refer to the factor label method, it's just making sure that, you know, you're canceling common factors, you're canceling common units, and that means that you've labeled the units that you're going to convert. And what I want to go ahead and tell you now is this. It says write the measurement you know, make sure that it looks like a fraction by dividing it by 1. And then we're going to complete the conversion by taking your original measurement, written as a factor, and multiplying it by this conversion factor. And I'm going to tell you something that you can write that tells you exactly what the conversion factor is and what you're going to be looking for. And this is why you have to know all of those relationships on that prefix chart that we did. Conversion factor, the one that we want to use is this. Conversion factor. We want to use the one that defines the relationship It's going to define the relationship between the unit that we have to begin with, the existing unit, which is the one that we have to begin with, between the existing unit and the one to which we wish to convert. And the one to which we are converting. To which we are converting. So what we have here, Conversion factor. Conversion factor is always going to be a ratio. It's going to be a fraction. Something A over B. And with the conversion factor, it's always going to have one unit in the numerator and a different unit in the denominator. And there's going to be a relationship that exists between these two different units. And that's what you're looking for. A relationship will exist always. You just have to discover what it is. Will exist. I can't spell, between the units. And sometimes, usually, much of the time, frequently, you might have to take first to your base unit, either to grams or liters or whatever the other thing is. Grams, liters, meters, and then to another thing. But this conversion factor, the conversion factor that we're going to look for always looks like a fraction, has one unit in the numerator, a different unit in the denominator, and the numerical part of the fraction is the one that defines the relationship that exists between those two different units. And there's any number of conversion factors. An example of a conversion factor in English is 12 inches is 1 foot. Or 1 meter in the metric system is equal to 1,000 millimeters. Or 1/10, I don't want to do 1/10, I want to do 1/100th of a meter is equal to 1 centimeter. So there are any number of these relationships that exist between different units. So what you're using for the conversion factor is the one that is the relationship between the unit, the unit that you started with and the one that you wanted to get to. So with that original problem, if we have the pencil that was measured in centimeters, 15.1 centimeters, we wrote that as a fraction over 1, and then we looked for the conversion factor that showed the relationship between two different units. And a lot of times in chemistry conversions, they might still use an X, but it's just multiplication. We wanted the relationship that was between the unit that you started with and the unit that it was going to. Starting from centimeters, we wanted to go to meters. And since numerators and denominators that are the same cancel out, if we want to get rid of that centimeters, the centimeters has to be in the denominator, and the meters has to be in the numerator. The unit that you're getting rid of cancels out. The unit that you're keeping is in the numerator. So now you've got the units that are related. That's an N, a very big N. So what's the relationship between meters and centimeters? Well, Max said that 1/100th of a meter is equal to 1 centimeter. So this puppy right here is the conversion factor. And this is where we had those like units cancel. Okay? So, you gotta understand this. You got to. So, example 1.1 says we have a rock that it weighs, or its mass is 14,000. This is example 1.1 on page 9. Can you believe it? Page 9. 14,351 grams. 14,351 grams. 30 minutes. And we want to No, I didn't. We are leaving about 5 till when I'm done lecturing. We have a 45-minute lecture. So we have a rock that weighs 14,351 grams. We're going to convert that into a fraction by writing it over 1. And now we want to multiply this by a conversion factor that is the relationship that exists between grams and kilograms. Now, since we want to change into kilograms, the kilograms is going to be in the numerator. So we have kilograms and grams. Now, what does this prefix kilo mean? Right, it means 1,000. So where does the 1,000 go? Is it 1,000 kilograms is 1 gram? Or 1,000 grams is 1 kilogram? Yes. A kilogram, this says 1,000 gram. So we have 1,000 grams. That's our conversion factor. 1 kilogram divided by 1,000 grams. So we have 1 kilogram divided by 1,000 grams. Now do you see here? What's neat here is this is just the words for what this says, and that's why it's so good to get that conversion, that prefix thing, because kilogram is 1,000 grams. So we have 1,000 grams. The grams cancel. So we now only have units. We have 14,351 divided by 1,000 kilograms. When you go divide by 1,000, you move the decimal point 3 places to the left. 14.351 kilograms. So you have the rock that is this impossible number to deal with, 14,351 grams. It's the same as 14.351 kilograms. Okay? See, that makes some sense, doesn't it? Okay, I'm getting lots of eye rolls. Okay, we're doing some of these on your own problems. We have a book that is 12,321 grams. And we want to know its mass in kilograms. So what do you do first? You take your original quantity, 12,321 grams, and we write it as a fraction over 1. And we write it as a fraction over 1. We want to express that mass in kilograms, so we want to have a relationship. The 2 units that we're going to be using is grams, are grams, and kilograms. Since we need to cancel the grams over here are going to be in the denominator. The kilograms are going to be in the numerator, because this is what we're working towards. And this is when we look at this, what does kg mean? Well, the K is our prefix, which is kilo. So this says kilogram. What does kilo mean? Kilo means 1,000. So what kg means is 1,000 grams. So in order to be able to multiply by some quantity equal to 1, yes, exactly correct, Matthew. We're going to have the conversion factor is exactly the same as what we just used. 1 kilogram is the same as 1,000 grams. The units of grams cancel. We're going to divide by 1,000, same as moving the decimal point 3 places, 3 units to the left, 12.321. And then you've got to make sure that you get those units in there. Okay. Well, now, if you've got the relationships down, then this next one is just really simple. We're not going to be talking about grams anymore. And what base unit are grams? Is it volume, mass, length? Gram is mass. Okay, so now we have a glass of milk.
Awesome.
This is, and the amount of the glass of milk is 0.121 liters.
And what milliliters?
Mm-hmm. Liter, be on the recorder, Matt. Liters are the base unit of volume. So how many milliliters? And see if you can get this done, kids, before I finish talking through it. How many milliliters?
Yeah.
Okay, do not look, okay.
Put it on your paper.
So,
Sure.
we need a relationship between liters and milliliters, so it's a little m, a capital L for liter. And we're putting our liter in the denominator because that's the unit that we want to cancel. So what does this say? What does little m, big L say? That says milli, which means 1,000th. Okay, so 1 milliliter is 1,000th of a liter. So this is what our conversion factor is. So we've rewritten our original problem, 0.121 liters, as a fraction by writing it over 1. Now we're going to multiply it by our conversion factor, which says 1 milliliter is the same as 1,000th of a liter. Nope, went the wrong way. Wrong way.
So 121.
Yep, it's 100.
Oh, so if it's behind the decimal, you go to the right 3 spaces. If it's a
Well, it has to do with division and multiplication. We're going to be talking more about this multiplying by power of
you
10.
confused us.
Because see, what we did before was we divided by 1,000. Not 1 and 1,000th, so it goes in the other direction. 0.121 divided by 0.001. Here, let me do it the old long division way. 0.121 divided by 0.001, you have to move the decimal point to 3. 3 units to the right, which is how you end up with 121. Okay, I need to, I need to know the time when it's about 10 till, okay? So this is equal to 121 is not the answer. 121 milliliters is the answer. It's starting to make sense. You're going to take the original, divide it by 1 to make it a fraction. Find a relationship between your old unit and the new unit that you want to change it into. Set it up so that the units divide. Okay, now we are doing one that's distance. And this says the distance from the 3-point line when you're playing basketball. The distance from the 3-point line to the goal is 640.08 centimeters. So what does that tell you about distances? What does this tell you about distances on a basketball court?
It's not very long.
Are they based in the metric system or the English system?
True.
English system, because I guarantee you when they're setting up, when they're marking out
Oh, I thought you
that
meant
3-point line, they're not going to have it in this centimeters. So we want to, but we are measuring it now in centimeters. We have the distance is 640.08 centimeters, and we're going to want to express that as a number of meters. So we need to find a relationship between what? Centimeters and meters. And where is centimeters? Is it going to be in the numerator or the denominator? It's going to be in the denominator in our conversion factor. What does centi mean? 1/100th, and how would you write 0.01? This is point, so right here, this says that 1 meter is equal to 0.01 centimeters, is that right? Do I have the relationship correct here? Centimeter says centi, which is 100th of a meter. So we're going to have, now
0.01
it's
centimeters.
right. So 100th meter is a
1
centimeter. And this is why, we need to have some actual pictures of, this is a centimeter, this is a meter, this is a millimeter, so that when we have them switched around, that you say, whoops, no. A centimeter, this says 100th meter, okay? This says 100th meter.
You dropped the notebook wrong.
Let's just look at this right here, cm, centimeter. And our prefix tells us that centi is 100, correct? So centimeter is the same as, how would you read 0.01? You would read that as 100th meter. So centimeter is 100th of a meter. I think so, Matthew, if that's correct. So our unit conversion factor is 0.01 meters is equal to 1 meter.
We both got it somewhere right.
Good. So we're going to have 640.08 centimeters over 1 times our conversion factor. We had the centimeter, and this says that 1 centimeter is 0.01 meters. Guess I should make that an M. Centimeters cancel. You have 640.08. We're multiplying by a number less than 1, moving this 2 units to the left, and our answer is 6.4008 meters. Let's see what we have here. Then, this is the picture that somebody just showed me. Something that looks like that. In other words, I take it that my class is not impressed with unit conversions. I need to know exactly what time it is now.
45, 46.
Okay, 6:46, not
5:45.
not done yet. Okay, let's stay, what happened to my conversion stuff? Okay, guys, just stay on. Now, how are we gonna, guys, this is really important, write this down. How are we gonna convert between systems of units? Now, systems of units are between the metric system and the US system. Your book, if you read this, the English system, your author's going to say you don't need to memorize these. Not true. Learn them. For distance, the conversion between the two systems is 1 inch is equal approximately
2.54 centimeters.
2.54 centimeters, exactly. For mass, here's that really strange thing. 1 slug,
I don't remember.
that's now 1 slug is 14.59 kilograms. Now a kilogram is over 2 pounds. So this is one honking big slug. That would be like the monster slug that crawled out of the Black Lagoon. It's a 30-pound slug.
Cool.
And then volume. And to go from The English unit of volume gallons, that is 3.78 liters. The ones that I suggest beyond a shadow of a doubt that you memorize, in other words, it is essential, it is mandatory. Learn those unit conversion factors. Learn those unit equivalencies. Okay? Now, this is from page 12. He says, the factor label method is one of the most important tools you can learn for studying chemistry as well as physics, and I'm going to say master it. Make sure that you can convert between them. Now, let's say that we want to, what's that number? Oh,
The library's
library's going to
closing.
close in 15 minutes. Okay. Adding and subtracting units of measure. This is something different than what we've been talking about. We have adding and subtracting units and multiplying and dividing units. And this goes right back to principles of algebra. For if you want to add or subtract units, and if you want to multiply or divide units. When you're adding and subtracting, it's like when you say 5x plus 6y, you can't add those because the units are different. But if you have 5x plus 2x, that would be 7x. When you're adding or subtracting the units must be identical. 6 ounces plus 2 ounces is equal to 8 ounces. 1 millimeter plus 10 millimeters is equal to 11 millimeters. 1 millimeter plus 2 centimeters. You cannot combine those. The units have to be the same. However, when you're multiplying or dividing units, they don't have to be the same. Because you can have as an answer, that's a 5, believe it or not, 5x divided by 6y. And that's an acceptable answer in algebra. So what that means is you're going to work with these just exactly with units. If you had 6x times 5y, what would that answer be?
30xy.
30xy. So what that means is if you have 3 feet times times 17 pounds. 3 feet times 17 pounds, Matthew, this is important, you're missing it, is 51 foot-pounds.
What? Oh.
The units don't have to be the same. John, don't just leave it closed or come in the whole way. This foot-pounds measure here is actually a measure of force. So if you're adding or subtracting units, they have to be identical. If you're multiplying or dividing them, they do not have to be identical. And here's my next page of notes. I can't lecture anymore until I turn it off.